This is the common block diagram of the transceiver system. Transceiver system contains both transmitter and receiver. For a transmitter, the power amplifier ensures a strong signal with a very high signal-to-noise ratio from the circuitry and boost its power. Meanwhile, the function of the low-noise amplifier is to use extremely weak and uncertain signal, such as associated random noise from the antenna, and amplify it to a more useful level. The duplexer is used to switch on and off the transmitter and receiver in order to transmit and receive signal from the antenna. Generally, there are two technologies to build the transceiver system. One is by using duplexer, and the other one is by using MEMS technology. Usually, the duplexer is a big component on the PCB. Meanwhile, the receiver and transmitter will be in the IC. The problem of using the duplexer is the design will be big because the duplexer is a big component. In order to solve the area issues stated just now, another technology can be used to build the transceiver system is called MEMS technology. By using MEMS technology, we can make the design area smaller because it is on chip. However, the MEMS technology is very expensive and complicated. So, what is the better way to build a transceiver system and solve the area issue? Here comes our proposed solution. We replace the duplexer with a CMOS digital controller. The digital controller consists of 6 input bits and 5 output voltages. The 6 input bits are pre-driver high bias, PDHB, pre-driver low bias, PDLB, driver high bias, DHB, driver low bias, DLB, main high bias, MHB, and main low bias, MLB. The output voltages are voltage bias for pre-driver, voltage bias for driver, voltage bias for main, LNA bias, and RF path switch between PA and LNA. The digital controller is powered by 2-volt voltage supply. Next, this is the full block of the digital controller. The digital controller is made up of 6 blocks. These 6 blocks are the band gap, 2-stage op-amp, buffer, digital bits, inverter and NOR gate. The inverter block and NOR gate block are inside the digital bits block. And now this is the proposed transceiver system. The advantages of using digital controller in our design is to save cost and to solve the area issues stated before. In addition, we have include mixers and VCO in our design as well. In our proposed transceiver system, we set all the digital bits to low in order to switch on the receiver. Meanwhile, to switch on the transmitter, we need to set the PDLB, DLB and MLB bits to high. The figure here shows the layout diagram of the proposed transceiver system. From the figure, we can see that the mixers is located at the top left side, the power amplifier is located at the top right side, the digital controller is at the middle of the layout diagram, the VCO is at the bottom left, and the low noise amplifier is at the bottom right. This is the layout diagram of the standalone power amplifier. And this is the layout diagram of the standalone low noise amplifier. Here comes the simulation results of the proposed transceiver system. In this project, we can conclude that the fully integrated chip size is small. The overall chip size of the design is only 2.1 mm times 1.8 mm. Besides, the power consumption of the proposed transceiver system is low. The power consumption of the design is only 450 mW. Furthermore, it is a low-cost design, since the duplexer is replaced by the digital controller.